Welcome to another lesson on mensuration. Okay, if you quite remember, we started mensuration. If you have followed our channel for some time, for some months ago, and then I taught on circle. Okay, the area of a circle, the circumference of a circle. We look at the length of an arc, and then area of a sector, and then perimeter of a sector. All right, so I want us to continue with the parts of a circle, and where I want us to, or what I want us to learn today is length of a chord. All right, length of a chord. But to get all these lessons that I have already taught, please, whenever you visit or whenever you open our channel, make sure that you go to the playlist. Okay, the topics are arranged there for you. All right, go to mensuration, circle. All right, so mensuration, look for circle, and then you get all that I'm talking about, so that as you learn from there, you'll be able to understand it well. Okay, because we have already built the foundation from somewhere, so that I can get a detailed lesson on mensuration, on the aspect of a circle. All right, so now let's continue with length of a chord. Length of a chord. So what is a chord? When I draw a circle like this, okay, we say that a chord is what? A straight line from one end of the circumference to the other end. So say AB. This is my chord. Okay, if it passes through the center, it becomes a diameter. So this is my chord AB. So I'm going to look at how we will calculate the length of this chord AB. And if we'll be able to calculate the length of this chord AB, then we should be able to know, okay, the angle this chord subtends at the center. So that will help us, and so that it will form a triangle, and then it will help us to calculate the length of this particular chord here. Okay, so this becomes our radius, and our radius, a radius is a straight line from the center of a circle to the circumference. All right, so this is our radius, and AB becomes the length of the chord. Okay, so how do we calculate the length of the chord? Let's assume that I have been given an angle at the center here as theta. Okay, I've been given an angle at the center here as theta. So how do I find the length of the chord? And you should take note that OAB becomes what? I become a triangle. All right, and this triangle here is an isosceles triangle, because these two lengths here is radius and here is radius. So we make the triangle what? Isosceles. Okay, and because the triangle is isosceles, then what we can do to help us is, let's draw a straight line from the center to the base or to the chord. Okay, so when I have a straight line from the center to the chord, it becomes perpendicular to the chord, and because this side is the same as this side, all right, it means that the perpendicular height from the center to the chord will divide the base into what? It will divide the base into two. So let me say, if here is C, then my length AC here become the same as my length CB or BC. Okay, so these two from A to C become the same as B to what? B to C or C to B, because this side is the same as this side. So any line I draw, it will divide the base into what? Into two. So the length will become the length of the chord can be divided into two as AC and then BC. And another thing is that because this side is the same as this side, this particular line here will also divide the angle also what? Into two. All right, so my angle AOC will become the same as angle COB. Angle COB. So the angle will also be divided into two. I can say that here is half of theta, and then here is also what? Half of theta. All right, so whatever angle is here, if it is theta, when you divide it into two, you get the angle here and the same as the angle here. So that when you put this together, you get the entire angle here. All right, which is half of theta. Okay, So that is that. So how do you even calculate? So in the question, you'll be given maybe the radius and let's take for instance an angle. All right, so when you are given a radius and an angle, because this triangle here, then what is the triangle AOC has become what? A right angle triangle. Triangle OCB has also become what? A right angle triangle. So if it's a right angle triangle and then I'm supposed to calculate any length or I'm supposed to calculate any angle, then what I can use is the trigonometric ratio, which is the SOHCAHTOA, or I can go by the Pythagoras theorem. Pythagoras theorem. So the Pythagoras theorem can help me. That is, if I'm to calculate one of the, if I know two of the side and I'm to calculate the third one, or if I'm given an angle and then I'm looking for the length, or if I'm looking for an angle, then I'll go by the SOHCAHTOA because it's a right angled triangle. All right, it's a right angled triangle. So that is what we can use. So for instance, if I have the radius and I have the angle, then I can calculate what? I can calculate here. All right. So if I have the radius and I have the angle, so let's assume that I want to triangle A, O, let's say C. If here is 90, here is 90. All right. And let's assume that my angle here is 30 degrees. All right. And I'm giving the radius as 10 centimeters. So in the question, I was giving radius as 10. I was giving the angle at the center as, let's say, 60 degrees. So that when I divide 60 into 2, I'll get the 30 degrees, which is here. So I was giving this entire angle at 60. So here will be 30 and here will be 30. Okay, so let's say here is 30. And then I'm supposed to calculate for the length of AB. One, I can calculate because this right angle triangle is the same as this one. Okay, this here is the radius. This angle here is the same as the angle here, and here is also a radius. So this right angle triangle is the same as this right angle triangle. Okay, they are congruent. So what I can do is that we have to what? We can calculate the length of what? One side, and then after that we multiply by 2 and we get the entire length of what? Of the chord, because this side is the same as this side. Okay, so let's assume, as I was giving an example, let's say here is 30 and then this is 10. So how do I calculate for this particular side here? The angle here is opposite, and then this side is what? My hypotenuse, because the 90 degrees is here. The side opposite the 90 degrees is the hypotenuse. So opposite on hypotenuse, what do I use? Sine. So I'll say sine 30 degrees is equal to what? AC opposite over the hypotenuse, which is 10. So that 10 sine 30 degrees will be equal to what? AC. And then what will be my AC? Use the calculator and then you find AC. So 10 sine 30 degrees will give us 5. So I'll have what? 5 centimeters. So it means that this side is 5, or let's say here is 30, here is 10, here will be 5. And if that is 5, and we are supposed to calculate, let's say, the length of the chord AB. So what do you do? Because AC is the same as CB, then I'll say that therefore my AB, okay, is equal to 2. We multiply 2 by the AC, 2 by 5, and that will give me 10 centimeters. So that will give me 10 centimeters. So you calculate for the length of one side, and then you multiply by 2, and then you get the entire length of the chord. All right, you see, that is so simple. So it depends on the question that you will be given. All right, sometimes you can be given the distance from the center to the chord, okay, and then maybe the radius. So if I'm giving the distance from this, so let's say the distance from the center to the chord, and I'm giving the radius, I can use the Pythagoras theorem, and then I'll find this particular side. Is that okay? So it depends on how the question is given and how you can calculate what? The length of the chord. The length of the chord. So let's solve one example on the length of the chord. Let's look at this example on the chord. A chord AB of a circle of radius 7 centimeters subtend an angle of 70 degrees at the center O. Find, correct to 2 decimal places, the length of the chord. Okay, so let's solve. You draw your circle nicely. Alright, a chord AB. So you draw your chord. So this is my chord AB. Okay, and the chord AB of radius 7 subtends an angle of 70 at the center. So let's say this is my center, and then I'll join to the center to get my radius. Okay, so my radius is what, 7 centimeters. 7 centimeters. Okay, and then the angle subtended at the center is 70 degrees. So it means that the whole of this angle here is 70 degrees. All right, and I'm supposed to find to 2 decimal places the length of the chord. So the chord here, so you just draw a line from the center to the base, to the chord. All right, so this particular line will divide the angle into 2. 70 divided by 2 give me 35, and here also be 35 degrees. All right, so we have 35 degrees here, 7 7. So these two right angle triangle, okay, become the same. So let me call here as, let's say, my C. So this is how you can do to find the length of the chord. So you can say that from triangle, any of them, maybe AOC, AOC. So I have an angle here, and this side is what, opposite, and here is what, hypotenuse. So I have to use the sine. So I can say that sine 35 is equal to what, opposite AC over the hypotenuse. So opposite over hypotenuse. So 7 sine 35 degrees is equal to my AC. All right, and then my AC will be, what is 7 sine 35? Let's use the calculator. 7 sine 35, that will give us 4.0150 centimeters. So that will give us 4.015 centimeters. All right, so we are finding the length of the chord AB. Okay, but what we have here is AC, and AC is the same as CB. So you therefore say that, therefore, length of the chord is what, AB, okay, is equal to 2 times 4.015. So 2 times 4.015, and that is going to give us our answer. 2 times 4.015, and we are going to get what, 8.03 centimeters. Okay, 8.03 centimeters. 2 times 4.015. So already this is even in 2 decimal places. Okay, so we leave our answer like that, 2 decimal places. So the length of the chord AB is 8.03 centimeters. Okay, I hope this is understood. Make sure to share, you subscribe, and then you comment. All right, I know I'll see you once again. Bye bye.